Hi everyone, my name is Thomas Kim. Today is May 13th, 2019. This is my 12th episode about the future of C++ programming, C++ 2A standard. If you ever watched my video about algorithm in C++, I almost always develop my algorithm using recursion. In this algorithm series, also in this cryptography, most algorithm I develop using recursion. Then I convert to loop. Most of the time, I initially attack the problem using recursion. When I found the solution using recursion, then I convert the recursion to loop. The reason I prefer loop over recursion is very simple. Loop is much faster and use much less computing resource. Loop can be much easier to vectorize and parallelize. Recursion is easier to implement, but it requires much more computing resources, both memory-wise and CPU time. Loop is harder to implement, but much easier for vectorization and parallel computing. So we can convert recursion to loop. We can convert recursion to loop, but not always. Recursion is basically stack plus loop. If the recursion is rather simple, then we can convert the recursion to loop without using stack. If the recursion is a bit more complex, then we still can convert recursion to loop with stack. However, when the algorithm based on recursion is very complex, we cannot. It is too much complex to convert to loop. So in this episode, the last resort for our algorithm is recursion using multiple threads. In this episode, we will learn recursion using multiple threads or multithread recursion. If you want to watch some videos about how I convert from recursion to loop, please watch these videos. In this video, I convert recursion to loop. Also in video, I implement algorithm using recursion, then I convert to loop for faster performance. There are lots of more videos about converting from recursion to loop. When the algorithm is more complex, implementing our algorithm based on recursion is much simpler and easier. After we successfully implement our algorithm based on recursion, then we can have a solid understanding about our algorithm. Then, based on our understanding, we can convert the recursion to loop. I have lots of videos how I convert from recursion to loop. If you watch my other videos, you will always find some complex algorithm I first develop using recursion, then I convert to loop. To follow this episode, you have to visit extensiontalkplayfun.com website and click this button to download the complete source code for our library. Then you have to watch system environment variable settings. If you don't make proper system environment variable settings, then you cannot follow this episode. Without further ado, let's get started. Start Visual Studio Code, then select CPP extension folder, then select tutorial folder. If you unzip this file, then you can find the CPP extension folder. In CPP extension folder, click subfolder tutorial, then click this button 012 cross thread recursion CPP. Control V, include talk play fun. We need chrono random, include talk play fun output HPP. I will add one more here, include talk play fun NCR MPR. Then we will include future, include we need atom, atomic. We will first create combination, how to compute the number of combination. We will be using this formula to compute combination. This is based on recursion. I will paste it here for your reference. Struct cross thread recursion. I'm creating a struct like this using big int t. We will define long. So return value is static big int t. This is return value. Single thread combination recursion big int tn big int tk. Okay, I will give a carriage return here. In this file, include NCR MPR, Ctrl V, view, editor layout, 2 columns, I drag and drop here. So I will find NCR. We will be using starting part. I will copy like this up to this point. I copied and pasted it here. Like this. Instead of R, we can say K. Okay, so K, 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 and here I will modify K. I will not talk about this algorithm, this formula, but I will just show you how to implement it in recursion. Okay. In this case, I'm using this formula. NCR equals or NCK equals NC n minus k, or NK equals n minus k. I am applying this rule because sometimes it's faster. Now here I will copy this formula once again. I pasted it here. So this is left hand side and right hand side. We compute like this. Return. We are calling this function again. n minus 1, k minus 1. Okay. Plus, I'm calling this function again. Recursively. Then this is k. So I'm basically using recursion. Okay. Then this amounts to this part. And this amounts to this part. So recursion is simple and pretty, but not very efficient. Okay, I implemented it. So here it returns, it returns, it returns. Now we created a function here. At this level, void loop versus recursion. We are first testing this first. Then int main big int t n equals 40, big int t k equals 12. Okay, so we are going to compute n k 40 12. Okay, this is also called binomial coefficient. I'm not sure how to spell it correctly. Binomial. In this website, binomial coefficient, you can read more. I will copy this link, copy, and paste it here for your reference. You can also read in this Wikipedia. This is actually the same. I will copy this and paste it here for your reference. Okay, so this is called binomial coefficient. Now we can try with two different ways. I will create a chrono random stopwatch. Talk play fun. Chrono random stopwatch SW. This stopwatch reset by default. Then std cout. We can use stream too, but I will just use it simple. I will use my own library. It is called talk play fun ncr npr ncr. This function is defined here. Okay, it is loop based. Okay, this ncr actually computes this binomial coefficient. It is loop based using rational number. It is loop based using rational number. We use talk play fun ncr, mpr, ncr, and k. Okay, then we display elapsed time. Elapsed, we can use stopwatch sw elapsed time. Okay, std, and there. I will copy the same function printout. I pasted it here. Once you display elapsed time, I right click, it resets the clock. So after displaying time, it resets the clock internally, so we don't need to reset separately. Now this time we are calling this function. Here we are calling this function. We just created this function based on recursion, like this. Now let's run this program. Here I will call this function. Then please note that this function is defined here, so I have to copy this and paste it here using cross-thread recursion. I create type alias, then I copy it because this function is defined here. This is a static member function. Okay, now we can compile. Start command prompt dir O12. So this is the file. We will be using Microsoft compiler or GNU compiler, whatever compiler. I will use Microsoft compiler, CLEHSC, STD, C++17. I will compile without optimization, O12 cross thread recursion CPP FE without optimization WO EXE. This is without optimization. 11 struct. Why is causing? Oh, I missed one curly brace here. Big int undeclared at 41. So we have to give CRT here. Okay, now let's build once again. Okay, CLS W. So the first is NCR. This is loop based algorithm. This is recursion based. It is still working. It is still running. It takes much longer time. So it takes 20,000 milliseconds. When we use my loop-based algorithm, NCR, the result is the same. This is the same result, but the time is hugely different. It takes just 1.5 millisecond or 1.2 millisecond in this recursion-based it takes 20,000 milliseconds. There is a huge difference. Now we will use some optimization switch. O2, this is optimized with, this is without, I would say OO, EXE. This is optimized version, OO. So it takes 2.3 milliseconds. There is almost no difference in this case, optimized or not optimized. This is optimized case. So it takes 12,000 milliseconds. So almost twice faster. This is optimized. But still loop is much faster, order of magnitude. It's almost 1 order, 2 order, 3 order, 4 order. 4 order of magnitude faster and more efficient. This loop-based algorithm. This algorithm. Okay? This algorithm. So you understand why recursion is terribly bad. Okay? Recursion is terribly bad, gives terribly bad performance. Implementing this NCR binomial coefficient or the number of combination is actually more challenging than you might think. If you want to implement this binomial coefficient NCR number of combination correctly, you probably have to watch this video. You first have to implement rational number correctly. You also have to understand Euclidean algorithm if you want to implement this algorithm correctly. Now I will close this file. Here I will copy this function. I copied and pasted. I will rename it cross-thread combination recursion. This is the part we want to optimize. So I will delete it. We have to start with try catch. Like this. This is the proper way. In this case, we don't need to use try catch, but this is proper practice, the better practice, okay? Then I will leave it here. If I will define some variables in this scope. Context pair int factor 2. I will just use 1. int max thread count. It will be static context pair 1. Static int max thread count factor times SDD thread hardware concurrency. Wow, we are calling function like this and it's bigger. Okay, remember in class initialize must be constant, but we can do like this inline. Wow, how it works. Inline static was introduced to C++ 17 standard. Okay, if you are using older version of C++, it does not work. So here I will create one more thread count. Here once again we are using magic. Inline static std atomic int thread count. We initialize with 0. Okay, so inline static is very useful and handy. We can even initialize object. Here, come down here again. If thread count is less than max thread count, else, so we want to limit concurrent number of threads. We want to limit the number of concurrently running threads less than max thread count. Okay, if thread count, currently running thread count is less than max thread count, then we are spawning more threads. So we are creating thread for this part. I copy here. We are creating for this part. I say ncr n-1 k-1. Okay, this is not value, this is future. So here std async std launch async. We will also define this as alias because I am teaching you C++ language. I have the liberty here. Context pair, I will use static context pair, static context pair or async std launch async. Okay, static context pair or deferred std launch deferred. Okay, then here we copy this, then our syntax becomes pretty. Okay, note that this thing is different. This is a std namespace. This is in this name scope. Okay, I hope you understand why I am using name scope, namespace, type name so much. So this is launch policy. Then we are calling this function. Wow, we are creating thread. We are crossing thread now. we are passing n-1, k-1. Wow, it is running like this. Why squiggle? Okay, it's working. Now thread is running now at this point. Although we are now creating this part. I copied okay. This part amounts to current thread n-1 k. This part runs in current thread. How? We are still using recursion. Copy, paste here. Now this is n-1 k. Okay. Now we are returning. This is returning, right? So now we are returning current thread. This is value, function return value, plus this is future get. So we are returning this thread is this function. This part is run in different thread. Calculate in a different new thread simultaneously. Calculate in the current thread. So we are using basically new thread and the current thread. So we merge them together and return. Okay. Else, this is so we limit the number of thread count. In else case, this is the else case. Okay. This is the else case. Copy. I copied and paste. If concurrently running threads are too many, then use current thread only. Okay. This is wrong function name. We have to copy this function name. Okay. Copied, pasted. Okay, we have to fix like this and save. Or here we created a new thread here, so we have to increase thread count. Okay, then I will create another one here. Auto RLT means return value. I will copy this code, cut, paste, and instead we are passing return here. Sorry. Semicolon here. Then before return, we have to decrease thread count. Okay, because we increased, then we run here, then we decrease. Actually, this is wrong practice. This is wrong this is wrong, but I will explain why in future sessions. I will address this issue in some future sessions. Now we completed, then I arrange like this. So in this case it returns here, it returns, but it should also return at this point. So I will put simple return like this. This is failed. This is to suppress warning. Okay, so this is not actually executed. Or I will just cut and I will put it here. Okay, to suppress warning like this. Now I copy this code, copied, pasted, then I rename it single versus multiple thread recursion. Okay, then I delete this part, then I copy this part, copy, pasted it here, then I copy this function name, cross-thread combination recursion, and I paste it here and also paste it here. Okay, so in this case we are using cross-thread combination recursion. I will put another space here to make them aligned. Now I copy this function, copy and paste it here, std cout loop versus recursion, std, and there I say single thread loop versus single thread recursion. Then I copy this once again, copied, pasted, single thread versus multi-thread recursion. Okay, and I will put carriage return, 2 carriage return here. Now let's build and test. We compile with the Microsoft compiler. This is optimized. Okay, OO, CLS, OO. So this is loop based. It took 1.6 millisecond. Single thread combination recursion is still computing. It took 12,000 milliseconds. Now cross thread took 8,000. Okay, in case of cross thread combination, this is recursion but using multiple thread. It took 8,000. Single thread took. Then I will create another one. Using too many threads is not good idea. I will copy it, I copied and pasted it here again. I modified smart cross. Okay, I modified the function name. I copy it. Then I copy it. Then I copy it. Here I will use single thread. Okay. Then I also use it single thread. Now let's try this one too. I will copy here another one. I copied, pasted it here. I put it smart and copy this function name. Copy. This is smart version. So I will put more space to align. Okay. Now we fixed like this. Now let's test once again. Now this time we will be using GNU compiler G++, std, C++17. We will give optimization switch O3, then O12 cross thread recursion CPP O GO EXE GO EXE. Hit enter. We are using GNU compiler. Okay, CLS GO. It took 2.3 milliseconds, almost 3 milliseconds. Wow, it took 10,000. It's much faster than Microsoft. Wow, half. Okay, this is a half. It's just 4,000. Smart cross is 4,000. Cross thread is 87,000. So this is 10,000. This win. Okay, this is using multi-thread. This is using multi-thread, but this is more smarter way. Okay, this is the one, smart cross thread combination recursion. All in all, this my NCR, this loop-based algorithm is fastest. Now let's compare with clang. CLANG, clang. I will give CO like this. Wow, CO failed. See, when you see this message callable, then you have to give this switch. Don't forget it. Emulated TLS. Don't forget this switch when you are using clang and you have this error message. Undefined reference to std once callable is built. So dir exe. So GOO is Microsoft. GO is we will build Microsoft again. We will build Microsoft again. This is Microsoft. OO is Microsoft. GO is GNU. CO is clang. Now we compare all three. OO, Microsoft. Now GNU. Now clang. So this is clang. CO is clang. In case of clang, when I optimized using smart cross-thread combination recursion, it's 6,800. It's like 7,000. This is twice faster than single threading case. Okay, in this case, GNU is faster than clang. In case of GNU, it's also twice faster. Smart cross-thread combination is twice faster. And in case of Microsoft, also twice faster, because I have 2 cores in my machine. If you have more cores, it will give much better performance. I hope you understand how we can take advantage of our hardware resources even in recursive function call using multiple thread. Please subscribe to my YouTube channel. Thank you for watching.